Okay, in the first lesson, we introduced the terms data model and data modeling, and I used this airline reservation application as an example to motivate and explain what those terms meant. So, just to repeat, a data model is simply the structure of the database that will support the business application. And data modeling is the process of coming up with that structure. Okay. So now for this lesson and the subsequent three lessons, so for a total of four lessons, we will be focusing and discussing details of the data modeling process. Now, before we begin that journey, I need to spend a few minutes on this intervening box, the DB, which says DBMS over here. That's the database management system. We said a few words about it in lesson one, but I want to elaborate on it a little bit. And as a result of that discussion, I want to introduce this concept of standard data models, okay? Because that will affect our data modeling journey as well as activities along the way, what that journey consists of, what activities it consists of. So just a few words about this middle box database management system. It's a piece of software. What does it do? So you have the structured database on the right hand side over here. So the business application will initiate actions, activities to operate on the database. So maybe it'll add content to the database, maybe it'll delete content from the database, it'll update the content of the database. Let's say the price of a flight changes, a passenger decides to cancel their reservation, so some content will be deleted and so forth. So there are actions that are initiated by the business application, business function, that need to operate on the structured database. All right. So the agent that executes those actions is this piece of software, the database management system. Okay. And for any database management system to function, it needs for the data to be not only structured, but structured in certain standard ways. The world cannot function without standards. Okay. So let me digress for a moment and just describe to you the role of standards in functioning, why standards are important, and then I'll come back to this database management system, and I'll discuss a particular standard for structuring data called the relational model, which will sort of underlie everything that we do for the next four classes associated with data modeling. So let's have just a couple of minutes discussion on the role of standard in functioning. The world cannot function without standards. Okay, so let's have that brief discussion, then we'll come back here. So let me take an example that we should all be familiar with. We have all traveled. So let's say what I want to do is I want to travel from Washington, D.C. to Istanbul for vacation. All right. And I'm going to go on a flight, use a flight, whatever airline it is. And the flight makes use of a wide bodied aircraft. Okay. It doesn't matter what the aircraft is, it's some wide body aircraft. So I'm going from point A to point B from Washington, D.C. to Istanbul. So that's the quote, the business function that I want to execute. And since I'm going on vacation, there are all these things that I need to pack: my clothes, water bottle, headphones, iPad, God knows what else. So all kinds of things I need to take from my source to the destination, from Washington D.C. to Istanbul. Now we all know that we all do this intuitively, but I just want you to pause and reflect on the role of standards in this very basic and frequent activity that we do. So I think we all know that when we pack our things for an international flight, we can't just pack them in any way that we want. There's certain standards. All airlines, for instance, have standards, have limitations on the sizes of suitcases. There's so many inches by so many inches by so many inches. They cannot be more than a certain weight. Let's say 20 kilograms for some airlines, 30 kilograms for others. But I think you're all aware that there are standards we have to follow in packing our things to get from point A to point B. So why are these standards so important? So here, this little picture that you see here is the equivalent of the database management system in our context. So think of all this equipment, this ramp that is taking the bags onto the aircraft, this little carriage that brings the bags from the terminal up to the aircraft. None of these things could be designed without standards. If the designers of this ramp didn't know how big suitcases could be or how heavy they could be, there's no way for them to design a RAM. Okay. So if for some reason, let's say you pack a suitcase which weighs 80 pounds, what's the problem with that? Okay. You have humans in the system who are working the ramp. They might break their back lifting your suitcase. So all these standards have to be designed, have to be specified with the functioning in mind. This entire system, this loading system, cannot function without standards. And there are lots of standards. We only see standards that apply to us in terms of our packing, but there are all kinds of other standards about for the construction of these ramps and or everything else around the aircraft. So I hope you see the importance of standards in any kind of functioning. The world cannot operate without standards. Okay. So coming back now to our context of a database management system, we have structured the data. This piece of software over here cannot function unless the data is not only structured, but it is structured in some standard way. Otherwise, it cannot function. It cannot be designed appropriately. Okay. Now, historically, there have been several different standard ways of organizing data. I'll just mention them here. Now, historically, let's say we had the hierarchical data model that organized data in the form of a tree structure. There was the network data model. There is the object-oriented data model. But over time, some of these other models have fallen by the wayside. And today, the most widespread, commonly used standard structure for a database is what is called the relational data model. And some examples of software packages, database management system that work using this standard structure called the relational data model are Microsoft SQL Server, which is the one we will use in our course here. There's Oracle database, there's MySQL, Postgres, IBM DB2. So there are different software packages, all of which function based on this standard relational data model. So for this next few minutes, I will have a discussion of what the standard data model looks like, the standard structure of a database looks like. And it's important to have this discussion because for the next 4 classes, when we talk about the data modeling journey that is starting from the business application and coming up with the structure of the database, once we know what the standard structure looks like, then the journey and what we do along the way in the journey will make more sense. So now we are going to have a discussion of what this standard model called a relational data model, what does it look like? What does it consist? What does that structure look like? What are the different components of that structure? And what are the main elements of that standard structure that we should keep in mind as we go through the data modeling journey? Okay. Now, the airline application that I've been using to motivate various discussion is a fairly complicated application. So to have a discussion that is more manageable and limited in time, I've picked a much more simple business application. The business application that I'm thinking about here is one where customers buy products that are produced by different vendors. Okay, so think of yourself that you go to Home Depot, you buy a saw or a drill and so forth, and each of those different products is sold by different vendors. And it could be Black and Decker or some other company. Okay, so that's the simple environment that I'm looking at here. The first thing to know is this standard structure called the relational model. In that standard structure, a database consists of a collection of relations. So here I have something called a customer, a relation called a vendor, invoice, line, and product. So in a relational database, the standard structure of the database is a collection of relations. Now you can think of any relation as a table. So every relation is a table, but we need to remember that not every table is a relation. Just because something looks like a table doesn't make it a relation. There are certain properties that these tables have to meet in order to qualify as a relation. But our starting point is, in terms of the relational model, this particular standard structure organizes the database as a collection of relations or a collection of tables, that we can think of that as a collection of tables. That's the starting point. So now let's dig deeper and reflect on the statement that I made a minute ago, that all relations, the customer relation, the vendor relation, invoice, line, and every relation is a table. But I also said that every table is not a relation. So what's so special about a relation? Let's take a quick look and see what those special characteristics might be. So now the first thing to notice about these relations, these tables, what makes them special, what makes a table a relation. So if I look at any one relation, so let's say I pick the vendor table. I think of this as a starting point, it's a table. What's so special about this table? First thing is you will not find any duplicate rows. In other words, you will never find two rows in the table that are absolutely identical in all respects. And that makes sense because this table is storing information about a vendor. So the same vendor should not appear twice. And you really shouldn't have two vendors that are absolutely identical in every respect. That means they are the same vendor. Okay? So you never have two rows that are absolutely identical. Same thing if I look at the product table over here, you cannot have two rows that are absolutely identical in all the columns, in all respects. Okay, so there should be something different in one of the columns at least between any two rows. Okay, otherwise you're saying that two different products. Each row represents a different product, but in its essence, they're identical if the two rows happen to be identical. Okay, so the first thing for a table to be a relation, you cannot have duplicate rows. Okay, the other thing is I should be able to uniquely identify any row. So if I want to identify a vendor, any one vendor in this table, I should be able to do so by specifying some characteristic of the vendor. So in this case, if I specify the vendor code, the thing to notice is no two vendors have the same vendor code. It's possible that two vendors have the same name, but they will not have the same vendor code. Okay. So if I look at in every relation, I should be able to uniquely identify a single row in the relation by specifying some by specifying some attributes. For instance, in the product, if I specify the product code, then I can uniquely identify any row in the product table. Same thing if I go to the customer table, then if I specify the customer code, if I know the customer code, I can uniquely identify any row in the customer table. So I must be able to uniquely identify any row in the relation by specifying this attribute. And this attribute that uniquely identifies a row is called a primary key. So here's a new concept that I've introduced, primary key. Every relation must have a primary key. Okay, I will summarize these things in the next table, but let's have a discussion over here. So let's come to invoice, for example, this particular table, this relation. What uniquely identifies a row in this table is the invoice number. So you can see that no two invoices have the same invoice number. That's what uniquely identifies any row in the invoice table. So I would say the primary key for invoice is invoice number. Now, let's look at this last table. I kept this table for last because it's a little more complex, but the same principle will apply. I just said that every relation must have a primary key that allows me to uniquely identify any row in the relation, and there must not be any duplicate rows in a relation. Okay? For a table to qualify as a relation, there cannot be any duplicate rows. So let's look at the table called line. Now, if I look at the first column, it says invoice number. That's not unique, isn't it? I have these first two rows which have the same invoice number. I have the next row, which is an invoice number by itself. And then again, I have invoice number 1003 showing up 3 times. So clearly, invoice number by itself doesn't allow me to uniquely identify a row in this table. However, if I think of invoice number and line number together, so if I tell you both the invoice number and the line number, then I can uniquely identify any row in this particular table. So if I tell you invoice number 1003, line number 3, then I immediately know that I'm talking about this row in the table. Okay, so here for this relation, the primary key consists of invoice number and line number together. This is what's called a composite primary key. We'll see that later on. but I hope you get the first aspect of a relation, namely that you can't have duplicate rows. In order for a table to be a relation, relations cannot have duplicate rows, and every relation must have a primary key. Okay. So what next? What are the other properties of the standard structure called a relational model? Okay. So in the first lesson, we had said that when you have different components of data in a structured database, these components are related to one another. They don't just hang there by themselves. And you saw the same idea in lesson one when we took the one big list and we broke it up, we decomposed it into related themes. So in a database, you don't, in a relational database, we said that the standard structure, the database consists of multiple relations. So here you're seeing a database that consists of 1, 2, 3, 4, 5 relations. But these 5 relations don't hang there by themselves. Their contents are associated with one another. And how do we know that? Based on the business application, I know that customers place invoices for certain products, and these products are sold by vendors. So obviously, just intuitively knowing how this business application works, I would expect the content of these tables to be related. Okay. So how does this, the fact that the content is related, how does that implemented in the relation in the standard relational model? So let's look at some particular columns over here. Let's look at the product column. So I look at any particular product. This first product over here. I'm sorry, I can't. I copied this picture from the web, and it's not entirely clear, but I'll read it for you as best as I can. This product code is 11QER31. It's a power painter, okay, 15 psi and so forth. So these characteristics of the product is not so important for our discussion right now. But let's get to the last column. It says V code is the vendor code. It's 25595. Okay. So do you see that immediately this 25595? So this particular vendor code should appear in, is what links it to the vendor table. Okay, let me find the vendor code that I can see in the list. 21344. Okay, here we go. Let's take the second product. It's 13-Q2P2. It's a 7.25-inch power saw blade. That's what the product is. Now, if I go to the last column, excuse me. If I go to the last column, I see a vendor code of 21344. And this is what tells me who the vendor is that supplies this particular product. As soon as I go over to the vendor table, here is I find 21344, and I find that the vendor is Gomez Brothers, and the contact name, the area code, phone number, and so forth. Okay. This particular column, this V code, is what is called a foreign key. So we introduced the term primary key before, and here we have something called a foreign key. A foreign key is what allows one relation to be associated with another relation. Okay, so a foreign key is the mechanism that you have to connect one relation with another. And this network of foreign key connections is what creates the structure of the database. So let's look at another connection. Over here, if I look at the relation called invoice, if I want to know who placed the invoice, who's the customer who placed the invoice, I look at the invoice number and I go over to this column called customer code 10014. That particular column immediately links me to customer Orlando Myron. Okay, that's particular customer. So here's 10014. So this column called customer code is another foreign key. It links the table or the relation invoice with customer. So relations can have foreign keys, and foreign keys is what allows one relation to be associated with another. So remember, a database is a structured collection of data. We said that in lesson 1. So in a relational database, in the standard structure, foreign keys will be used to associate one one relation with another, and that's what allows the software. If you come back to the database software, that's what allows the software to navigate its way from one relation to another relation, and so forth. That's is the foreign keys that allows it to move and gather the data that it needs from the database to support the business applications. Okay, so I hope you got the concept of a primary key and a foreign key. Those are essential elements of the relational data model. There are certainly many other nuances to the relational model. We'll see those as we go along, but we need to be able to keep these basic characteristics of the relational model in mind for the next 4 classes as we go through this data modeling journey. So let me summarize the discussion that we've had about the standard database structure. I hope by now you've understood the importance of having a standard structure. Otherwise, the database management system cannot be built. The software cannot be built. It expects the data to be structured, not just structured, but structured in a particular format, okay, which is the relational model. So just to recap, a database in the relational model, a database is a collection of relations, okay. A relation, you can think of a relation as a table. All relations are tables, but all tables are not relations. A table must meet certain conditions in order to qualify as a relation. What are some of those conditions? There can be no duplicate rows in a relation, and every relation must have one primary key, exactly one primary key. And a relation can have a foreign key, and foreign keys are really the only tool that are available to you to establish association between relations. Okay, a relation may have 0 or more foreign keys. Now, these two rules, the entity integrity rule and they're just fancy names for a very basic idea. I'll go back to the picture and explain those to you, but let me just state them first. These two rules are absolutely central to the standard relational model. One is called the entity integrity rule, and all that the rule says is that the primary key cannot be null. The referential integrity rule, it's a mouthful, but let me say it, and then once you see the example, I think it'll be pretty self-evident. A foreign key in a relation must either match the existing primary key, excuse me, value in the related table, or must be null. Okay, so that's a mouthful. Let's see how it's a very basic idea. So let's use this example that we've been talking about for the last few minutes. So the entity integrity rule says that the primary key cannot be null. So that's pretty self-evident. If I look at the vendor relation over here, the vendor table, its primary key is vendor code. Remember, we said every relation must have a primary key. So here's the primary key for vendor is vendor code, meaning every vendor's V code must be unique. You can't have two different vendors with the same vendor code. If it's the primary key is the attribute that allows you to uniquely identify any row. Since a row is a specific vendor over here, you can't have two rows with the same vendor code. Similarly, you can't have a vendor with the vendor code missing. So otherwise, I won't be able to imagine that for any particular vendor, let's say Brackman Brothers, this vendor code is missing, that it's null. Then I can't identify the vendor because it's the vendor code that allows me to identify the vendor. So primary key cannot be null. Other things could be null. For instance, it's possible I don't know the phone number of Brackman Brothers. Okay, but I wouldn't even be able to identify Brackman Brothers if the vendor code, the primary key, is null. So that first rule, the entity integrity rule, makes intuitive sense from a business application standpoint. If I am to identify a vendor, if I am to identify a customer, I must know the primary key of that table. So primary keys cannot be null. So that is the entity integrity rule. Now, the referential integrity rule. So let's pick a simple example over here. A few minutes back, I pointed out to you that customer code in this table, invoice, is a foreign key because it allows me to connect invoice with customers. So when I look at the invoice and I see a particular customer code that tells me, oh, this is some specific customer, so I go back to the customer table and use that customer code to identify the customer and whatever details I have about the customer. Now notice what would happen if I have a customer code suppose I have a customer code in the invoice table which says 12000, okay, and I don't have a customer whose code is 1200. So they don't match. I have a customer code in invoice that does not match an existing customer code. What's the practical translation of that situation? It means an invoice has been placed by a non-existent customer. So I have a customer number that doesn't match an existing customer. So that means an invoice was placed by a non-existent customer. Obviously, that doesn't make sense. So the referential integrity rule says that if you have a value for the foreign key, if the value exists for a foreign key, it must match a primary key in the related table. So customer, the table customer is related to invoice. If I have a value for the foreign key, it must match an existing primary key in the related table. That's the first condition. There's a second part to that statement. It says or must be null. That simply means that if the foreign key does not exist, if the foreign key, if there's no value, it must be null. Okay, so I'll take an example over here. This particular product is a sledgehammer. I can't quite read the product code, but it's a sledgehammer. It's a 12-pound sledgehammer. And if I go over to the vendor code, this particular column is a foreign key because it links the table product to vendor. Yeah, I can use the foreign key and go back to vendor and find out who the vendor is and find out the details of the vendor. Okay, but here for the sledgehammer, here's the sledgehammer. This value is null. It doesn't exist. Okay, that simply means I don't know who the vendor is who's supplying. Maybe I'll know later, but as of now, I don't know who the vendor is. So here is a foreign key value that is null, and that's perfectly acceptable. Okay, I don't know who the vendor is who has supplied the product, and when I come to know about it, I'll fill this in. So that's the referential integrity rule. So remember these two rules, the entity integrity rule and the referential integrity rule. Those two are important characteristics of the relational data model. Okay. So to wrap up our discussion of the relational data model, for this software, the software that manipulates the database, for the software to function, it expects data to be structured in a standard way. All the commands inside its internal workings, just like the ramp and the carts in the airline packaging, the ramp operations process, that equipment. Similarly, the database management system software over here expects the data to be structured in a particular standard way. And for our purposes, that standard way is the relational data model. So at the end of our data modeling journey, when we get to the third and fourth classes in this journey, data modeling journey, you will find that we have taken the information requirements of the business application and gone through step 1, step 2, step 3, and so forth. At the end of the journey, the structure that we will be coming up with will be this in the form of the standard relational data model. So it will look like a bunch of tables that have primary keys, foreign keys linking them with one another. That's why this understanding of the standard structure, which is a relational data model, is so important. All right. So with this introduction to the relational data model, we can subsequently begin our journey, our data modeling journey.